Good morning, grade 8. Today we are going to start the lesson 3 electric circuits. We mentioned before in lesson 2 electric current. The electric current continuous flow of electric charges in a closed or in unbroken path. Yes? So the electric current needs a path to flow through it. This is path called electric circuit. Yes, called electric circuits. We have types of electric circuits in which current flow. In this lesson, we will know these types. Firstly, Ohm. Ohm is a scientist. Ohm in second lesson, in electric current lesson, told us about how the electric current can move in a circuit, and also how the resistance can resist the flowing of charges, and the voltage is the difference in electric potential of the current between 2 points. Yes? So, Ohm observed what? There is a relation, or found that current and the voltage and the resistance in a circuit always related. Ohm observed or found that current, voltage and resistance in a circuit always related. So Ohm's observed that voltage in a circuit changes, so current change. Okay? So changing the voltage in a circuit changes the current. Okay? But does not change the resistance. Okay? So Ohm made a law, and this law called Ohm's law. Ohm created a law describe the relation between voltage, current and resistance. Resistance equal voltage divided current, or voltage equal current time resistance. So look, the relation between voltage and the current, voltage change, current change. Yes? So voltage equal current time resistance. Voltage, the unit of voltage, volts, V, and the unit of current, ampere, A, and unit of resistance, ohm, according to Ohm, or the scientist Ohm. Okay? So don't forget this relation. Voltage equal current time resistance, or resistance equal voltage divided current, or current equal voltage divided resistance. Yes? We can change the formula of the law. Second, what is a circuit made of? This is our topic, electric circuits. What is a circuit made of? All electric circuits have these basic features. Number one, devices that run on electric energy. You have to put the electric circuit in a device, yes, that allow current to flow. So we have devices that run on electrical energy. Number two, source of electrical energy, like battery, cell. We have source of electrical energy, yes, to supply the circuit with energy, with electric charges. Okay? Number three, conducting wire. Yes, we mentioned before the materials, conductors or insulators, because conductors allow electric charges flow. Yes, due to the electron held loosely. Yes, the electron held loosely in the atoms. So we have three main or three basic features for making any circuit: devices that run on electrical energy, number two, sources of electrical energy, and the conducting wires. Energy source: batteries or power plant that supply the building. They supply the voltage. The energy source means supply the voltage that causes current flow. In a battery, current flows from positive to the negative. We mentioned before when we spoke in first lesson static electricity and the electric charges. Yes, we mentioned the positive pole, the charges moves outward. Yes, and the negative pole or negative charge, the charges move toward the negative. Charges move toward. So during flowing current in a circuit, in a battery, current flow from positive outward toward the negative. Okay. Number two, energy always conserved. Energy always conserved in a circuit. This is according to the law of conservation of charges. Yes, energy is always conserved in a circuit. Electrical energy change into other type, transformation of energy. Yes, electrical energy change to heat. Electrical energy change into light, like the bulb will light up, like the toaster or microwave change electrical energy into heat energy. Like any instrument produce sound, so electrical energy change into sound energy, and so on. So energy always conserved. This is number one, energy sources. Number two, electrical circuits are connected by conducting wire. Yes, sure, conducting wire, conductor material, yes, which make complete circuit and allow charges to flow. So conducting wire make complete circuit and allow charges to flow. And also we have switch to control current flowing. Switch on, so the current flow. Switch off, the current cannot flow because the circuit is opened. When you switch off, the circuit is opened. When you switch on, the circuit is closed. Yes? So switch control the current. Opening switch means breaks the circuit. Breaks the circuit. But to allow electrical charge to flow, you have what? You have to close or make unbroken circuit. Yes? Unbroken circuit. Battery. Look, battery, this is the source. Look at the switch and look at the lamp is a device that allow current to flow through it. We have two types of electric circuits, as I told you. Electric circuits in which the components connected in a series way. In this case, I can say this is series circuit. And circuit in which the components of the circuit connected in a parallel like this. In this case, we can say this is parallel circuit. So what I mean by series circuit, a circuit that has only one path from positive to negative, only one path, and I can connect more than one bulb, 2 bulbs, 3 bulbs, and so on. Circuit that has only one path for the current to take is very simple to design and build it. It's easy to make it. Yes? Look at page 178 in your book. Look at the series circuit with 3 bulbs in page 178. Yes, the current pass through each bulb. Yes, the current pass through each bulb because all connected to the source. Yes, type. Look at the brightness of the bulb. It's very important to know the advantage and disadvantage of each circuit. In series circuit, we have disadvantage. Light bulb in series connected to each other, so if one burn out, all the circuit is broken. Yes, and the other bulb will not burn or the light goes out. Why? Because all connected to each other. So if you cut one, so I will open the circuit. Yes, I will break the circuit. So no continuous flowing for current. This is disadvantage for series circuit. It's simple to build series circuit, but this is main disadvantage. Number 2, the brightness. The light bulb in circuit become dimmer as more bulb added. If you add 3 bulb, the light dimmer. If we add 4th bulb, the dimmer also. So if because resistance increases, because all bulb take from the same source, and each one take, the first one take 10, say 10. The second take from the 10, so 10 become 9. The third take from 9, so become 8, and this one becomes 7, and so on. So as the number of bulbs increase, the light bulbs will become dimmer as more bulbs added. If resistance increases, the current decreases. So this is increase the resistance. If you add more bulb, this is increase the resistance. What happens when the resistance increases? The current decreases. Yes, the current decreases because we have relation between current and resistance. Yes, if current decrease, resistance increase. If resistance decrease, current increase, and so on, because both of them time to each other, like 3 times 4, 2 times 5, 6 times 2, and so on. One increase, other decrease. One decrease, other increase. And the voltage doesn't change. Look, voltage doesn't change. What about parallel connection or parallel series? Look at the parallel, a circuit that has more than one path. Yes, this is 2 paths. If you add more bulbs, so we make 3rd path, and so on. Yes, several paths for current to take. Is there any disadvantage for this connection? No, we have advantages. Number 1, if one or there is we have more branch. Yes, if one bulb goes out, the others remain lit. The other remain lit. Why? Means because every bulb with its own connection, so this connection doesn't affect the second connection, and so on. Look at page 179, the parallel series, or the parallel circuits. Parallel circuit, yes, all connection in any building or in house, in your home, all connected in a parallel circuits. Okay, parallel. Yes, because if one goes out, the other remain lit. So when we add new branch or other branch in a parallel circuit, the resistance decrease, not increase. In series increase, the resistance increase, but in parallel the resistance decrease. Yes, and the current has more passes to follow, so current increase. As resistance decrease, current increase. Yes, we mentioned current time resistance equal voltage. And the brightness doesn't affect. The brightness doesn't affect, but in series the brightness what gets dimmer. Yes, so it's easy to compare between parallel and series connection. Yes, parallel and series circuits. Okay, so the advantage of parallel circuit, if there is a break in one branch, charges can still move through the other. So if one bulb goes out, the others remain lit. Number 2, when you add branch in parallel circuit, the resistance decreases and the current has more buses to follow, so the current increases and the brightness of light bulb does not change. Yes, look at the page 179. The brightness is still glow, but look at page 178. The brightness of the 3 different bulbs get dimmer. Yes, thank you all of you.